Okay, so now that we have the face done, don't forget to unlock it. Just give just a quarter, not more than half of a turn to this lock over here. So the next step is to just get the tool close enough to the material stock. So if we get like on this position, you might feel you're trying to get just like a small feeling of, for instance, right here you can feel that it's just a small amount of resistance from the material. Okay, so that's about good for that. All right, so since you have in your lab description, you're going to have something like this. So you're going to need to mark the distance of the 0.1 inches for the thickness of the ring. And also, and this as I'm doing this, you can start working on your list of operations for this part. We're gonna try to make a mark for that limit, okay? And then we're gonna make we're gonna try to cut a slot for getting the ring eventually removed from the material stock, okay? So the idea is to have this mark and then make a slot deep enough for the ring to come out once we start making the drills for this part, for the inner diameter, okay? So I'm not going to show like the calculations because that's part of your lab work. So just keep in mind that there's one thing that you need to consider for the motion of the card, and that is that you have these lines, as I mentioned, that each line represents, in this case, it's indicated as a 1,000 of an inch. So there's two ways to consider this. That is that one line is 0.1 inches in direct measurement or indirect measurement. Okay, that would mean that you could either have, if you move it one line, you could either have 1,000 of an inch just to affect the overall diameter, or 1,000 of an inch to affect both ends of the diameter, eventually having twice what is indicated here. Okay. Also keep in mind that these slates that are kind of small, and there are particularly these models that you're going to use for lab number 1 and 2. You might not have the same quality, or you might have some play issues with the card. So just keep in mind that you're not going to, for these slabs, you're not going to exactly have this from this motion. But just keep in mind that you need to have that into consideration, that you need to calculate how many lines you're going to need to move this card in or out to obtain the diameters specified in the blueprints. And that is going to help you to create or to calculate the reduction of the diameter that you need. Okay. So now the other thing is you need to remove this much material from, so you need to have this depth. So what I'm doing is I'm just trying to set this caliper to obtain a position at which the tool is going to be able to cut that much. For instance, at this position we have around that. Okay, so if we just turn the chuck, we're going to be able to see a small line that is forming for the amount of material that it's just removing. Okay, so I'm doing this by hand, and that is creating this tiny line over here. Okay, so that is going to be the reference for the next operation that is doing this, that is working with this tool. Right, let me just remove this from here, And I'm gonna align this part, or this tool, with the face. The best way to do it is with a machinist block. We're gonna have those for the lab, but I'm just gonna show you one way that you can do it. That is trying to create some parallelism between the blade and the face that is the reference for all of this. And it is that if you can see, there's no gap in between the tool and the face. Okay, so let's snug it and bring this out, and then let's bring this over here. So while we're doing this, just keep in mind that also the position of the carriers and of the tool, you need to keep in mind that you're going to try to avoid any possible damage or interference with the chuck jaws and the carrier. So far you can see that this is moving properly, so we're not going to have that issue. So just now let's try to make the blade to get closer to this. Okay, and I think we are about there. Okay, so let me just turn this on. Okay, and just make it spin a little bit slowly. All right. So far, as you can see, it's close. So we can just make it even closer. And I think we are now getting some material removed. So let me turn that off. And then, because this is going to be similar to our facing operation, let's lock the card again. And as I mentioned, you're going to need to do the calculations for this, all right, so that you can have your the diameter that you need. Okay, so I'm just going to show you the first passing that I'm going to do, and then I'm going to cut it. On the next video you're going to see the end result, so that you can work based on that. Okay, so let's add some oil over here. All right. And starting from here, just keep in mind the material, it's 0.75 inches in diameter, so we're trying to reduce it to the slot we needed with we needed the slot to be all the way down to 0.625 inches. So you need to do the calculations for that. And I recommend you to, considering the initial diameter of the material stack, 0.75, you can, for instance, make an initial cut with 5 lines. Once you have that, you can measure that mark, calculate how many thousandths of an inch you actually reduce, and then recalculate if you find a difference between what you're actually getting from the machine and what you got from your calculations. All right, so we're back just for the last part of the creation of the slot. So just going to make the last few turns. You see a lot of chips coming out, and I think that's about it. Okay, so now we turn it off. You can remove the blade. Okay, and we have that slot. Okay, so before you can move this, always remember to remove the lock. 1/4 of a turn will do the trick, and that's it. So now you have the slot that you're going to use to remove the ring at some point. You have this now disc. Also, we need to remove some of this material. Just keep in mind that we have a material stock of 0.75. We need this diameter at 0.725, so that we need to remove 25 ounces of an inch. Okay, so we're gonna. It's not recommended. It's not a good option to use this tool. It's not that you cannot do it. It's not recommended. So let's switch back to the previous tool that we were using. Okay. Also try to get it closer to that position. And this is just like ballparking the position, the best position for this. And for the cutting on the surface, the machining of the surface, we don't need that much of the of the same alignment that we have with the other tool. It's just that we need just to have enough room to get this flank to cut properly and the other flank to do it as well. Okay, so I'm just trying to also get to ballpark a good position for the tool to be in touch with the surface. So for instance, right here, we already touching. Probably was just too much. Okay, now we have a lot of chips over here. All right. So keep in mind that again, you need to do the calculations of how many lines you need to put in for this. All right. So right now, for instance, if I were to, let me just bring it out a little bit more. For instance, if I were to do this, I'm already cutting a little bit of material. So I'm going to start from that position. So just a reminder, you have 0.75. You need to remove 25 thousandths of an inch. So you need to do calculations. If it's direct, would be like the 25, or indirect, okay, that would be 25 thousandths. How you can apply it here. Okay. So now let me just remove the tool a little bit and get some. Again, I don't recommend you to do like all the passings on one shot. Keep in mind that could just these lathes particularly don't have that much power just to remove big chunks of material. So just go and like maybe 5 lines at a time, or maybe 10 lines at a time. That way you can actually know that how much you're cutting. Okay, so I'm just going to move it 5 lines and increase the velocity. And let's just start doing this. and based on your calculations you need to keep on adding lines to get to the appropriate diameter. Alright, now that we finished cutting, let's check the diameter that we're getting. 0.725, so we are about right. Okay, so before doing the drill for the hole, there's one note that you have in your blueprints that it's remove all burns and loose material from machine features. So there's two ways you can do that. Initially we're going to do one part, at least for this end and this edge over here. We're going to do that with this file, just slowly. You don't have to add a lot of pressure, and just be careful just to move the file against the rotation of the chalk, just smoothly. You need to add a lot of pressure. All you need to do is just remove the sharp edges, at least on this part. And also on the other half, just be careful not to hit the jaws of the chalk, and that's it. That's all you have to do for that part. Okay, you pass your finger over here. You're gonna feel still a little bit of an edge. Again, just do it smoothly. You don't have to a lot of pressure. Okay, and of course be careful not to damage the surface that you already machined. And you're gonna feel this is gonna be way different. Be careful not to get yourself a cut. So that is one part. So the next thing is, now let's remove the tools so we can use the drill bits. And as indicated, we're gonna use the drill bits in series. Okay, we're gonna first use the drill for having the central hole, the hole that we're going to use as a guide for the rest of the drill bits. Okay, so that is in the next video.